Hi, this is Dr. Hassan Chaudhry and I'm the Director of Studies for the Architectural Engineering program at Heriot-Watt University, and today I'm going to show you what we actually do in an architectural engineering laboratory. We will be talking about cooling towers today. So Matt, can you tell us a bit about what cooling towers actually are?
Yeah, so cooling towers are a way to basically cool down water in a manufacturing process that uses water to cool down the machinery or whatever it might be. We then need to cool the water down, so we do that often by using a cooling tower. So that's what this setup is simulating here.
Right. So you may have noticed at the back of your ACs generally are very hot. Now your ACs at the back use a condenser, which is also like a cooling tower. Now in a small scale application, we use window ACs, but in a large scale application, as you've been driving by UAE roads, you would have noticed structures like these, which are essentially cooling towers in a very larger picture. So what we are trying to do here is to replicate a cooling tower operation because they are fundamental to building HVAC, which is heating, ventilation and air conditioning. So let's just start on with how are we measuring air temperatures. So what are we using to measure air temperatures here, Matthew?
So if you notice here, all these wires are all connected to thermocouples, and we have these in various places around the tower, so we can see what's happening in all different areas. So as you can see from this display, you can see all different temperatures at different areas. So the hot water coming in at the top, the cool water at the bottom, and the air temperatures in between. So you can see how the whole system works.
Right, so we have got two thermocouples at the hot water inlet. We've got a few thermocouples at the cold water inlet, and we can now see what is the temperature between the hot water and between the cold water.
Yeah. So number 5, so that's the hot temperature, the hot water going in.
Almost at 50 degrees.
Yeah. And then number 6, so it's got 10 degrees by the time it's got to the bottom. And we can adjust the flow rate of the water, the flow rate of the air to see the comparisons between the two.
Right. So what we can actually see here is that normally the condenser section of an AC can get as hot as 50 degrees Celsius, which is why we feel hot at the back when we stand off an air of a window AC. But and with the cooling tower, we can cool it down by almost 10 degrees before it enters the atmosphere, and that's where we see the steam forming. So, and what is this for, Matthew?
So this basically, down here we have a water tank which is heating up the water and sending it through the pump, and this keeps the level topped up, so it keeps it at a minimum level. But you can also use it, if you look up here you can see the condensation forming, so this kind of gives you an indication of how much water is evaporated throughout the process.
Right, yes. So as the water turns from liquid into steam, that's the process that we're trying to mimic here. And just a quick final question, Matthew, on these blades. So are these blades used to channel water downwards?
Yeah, exactly. So it separates the water out into these blades or fins, which increases the surface area of the water, and as the air passes over them, that increases the efficiency of the cooling.
Right. Yes. And well, that was our cooling tower. It's quite warm now when I touch it. And let's move you now to the next activity that we're doing in the lab, which is on solar tracking using Heliot-Watt. Hi, John.
Hi.
So what are we doing here?
We're doing our 3D printing using these smart technologies. And 3D printing is transforming construction and building design process. We have this model being printed by these 3D printers and have it been tested by these kilodons. We can simulate air movement throughout the day and throughout the year, and we can design our buildings in corresponding to the climate. So more sustainable design can be happening at the design stage. Create renewable energies in our building designs. Using photovoltaic could generate electricity for the consumption of our buildings and power the mechanical system of our buildings, make our building more sustainable and smart.